We're going to continue looking at probability, and in this set of videos we're going to look at some specific cases of probability, and then we're also going to move on to what we call conditional probability as well. So let's first look at coin flipping. Coin flipping seems to be a very popular and well-known probability situation. And what we're going to look at right now with coin flipping can also be applied to similar what we'll call for now two event cases. Later on we're going to define two event cases in lesson 8. Okay. So let's look at maybe the idea of flipping one coin. All right, when we flip one coin, we often call the two outcomes heads or tails, and this comes from the idea that many coins, especially in the United States, one side of the coin has the head of maybe a president on it, and then on the other side there's some other kind of impression. Now, technically, if we go back to the Roman Empire or Latin language, they were sometimes called the obverse, which is heads, and the reverse, which is tails. But we're just going to call it heads or tails, okay? And there are two possible events when you flip a coin, and we call those two events heads or tails, which we're going to refer to as capital H or capital T. Capital H obviously representing heads, capital T representing tails. Now, in order to understand this from a probability point of view, we have to be able to quantify it. We have to turn it into numbers. So we're going to call the outcome the number of heads. And so when you flip a coin, if you get a heads, then that means that you achieved one head. And if you flip tails, that means that you achieved 0 tails. And so our outcome, which we'll refer to as our random variable will be the letter X, and there's two possibilities. X can either result in 0 heads, and that's when you flip tails, or it can result in 1 head when you flip heads. And we call these two numbers, 0 and 1, that would be called the sample space for the outcome number of heads. But now suppose we wanted to flip 2 coins instead of just 1 coin, okay? We can call one of the coins coin A, and we can call the other coin coin B. Now understand, this does not have to be 2 coins. It can either be 2 separate coins, or it can be one coin flipped twice, okay? So flipping 2 separate coins is the same thing as flipping one coin 2 times in a row, okay? That would be the exact same thing, okay? So if we were to flip either 2 coins or one coin 2 times, the first flip we would call coin A, and the second flip we would call coin B. Now you can see that I have drawn coin A in blue, and I've drawn coin B in red, and I did that to try and help you better understand how the probability works. We know that when we flip the first coin, coin A, the out can be heads or tails, and that's just like flipping one coin. That's essentially what we talked about up here. Flipping one coin, the events are either heads or tails. And then if we flip coin B, it's the exact same thing. We can either have heads or tails. And so we can actually graph on a chart what these possible events are. So if we create this chart here and we put the results of coin A on the top, okay, we have possibility heads or tails, and then we put the events of coin B on the side, heads or tails, we can now cross them over, okay? So we can put, here we can put the heads of coin A along with the heads of coin B, and our outcome winds up being heads. That means we flipped 2 heads with the 2 coins. Let's see what the rest of them would be. So you can see we have heads here, and then look at this one right here. This is tails heads. That means that the first coin is tails, but the second coin is heads. And then this one right here looks very similar, only the heads is first. That's because on this one, we got a tails on the first coin and a heads on the second coin. This one right here is actually a different event. On this one, we got a heads on the first coin and a tails on the second coin. And you may be thinking, but these two are the same thing. Well, they're the same outcome, but they're not the same event. In this one, the first coin is a tails, and in this one, the second coin is a tails. And in the world of probability, that matters. And then in this event right here, we can see that both coins are tails. And this is a total of 1, 2, 3, 4. 4 possible events that could occur, okay? And so that's going to affect our probability. And now we want to try and identify, just like up here, we called our outcomes the number of heads. Let's do the same thing for flipping 2 coins. So if we call our outcome number of heads, we can look here and we can see, okay, well, in this outcome right here, 2 tails, that's 0 heads. So that's 0, that's one possibility. Let's draw that a little bit smaller. Another possibility is this one, tails and heads, that's only 1 heads. This one's heads and then tails, that's also only 1 heads. So both of these situations are an outcome of 1 head. And then this one right here is an outcome of 2 heads. And so our sample space has 3 possible outcomes, either 0 heads or 1 head or 2 heads, okay? Now let's move on to looking at 3 coins. So now if we wanted to flip more than 2 coins, we're going to have to do something creative because we're not going to be able to do the graph with the 2 heads on the top and the 2 heads on the side. So what we're going to do is this, let's say that we're flipping 3 coins. If we're flipping 3 coins, what we're basically going to do is we're going to create a graph where we take all the outcomes from 2 coins and put them along the top. So we'll put the heads here, we'll put the heads tails here, the tails heads here, and then what we'll do is we will put on the side here 1 coin, and 1 coin is just going to be heads and then tails. And as you can see, once again, I've color coded them. I've made the first 2 coins are in green, and then the third coin is now in orange. And so what we basically do is this, is we fill in here, we would put the heads in 2 places, okay? Then we put the heads tails also in 2 places. We put the tails heads first, here, and tails tails. So we're basically filling in all of the outcomes from the top of the graph, and then after that we will add in the third coin. All right, so you can see here we have this heads here, and now we're going to add the third coin, which is a head. So we'll put that head here. Then we're going to add this coin over here. We'll put a heads here. We'll do the same thing here. Put the third coin here. Put the third coin here. And then in this row, we'll put all tails. So we'll put a tails here, and a tails here, and a tails here, and a tails here. And so how many events is this? Well, we have 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. That's 8 unique events that could occur. Now again, you may say, but some of them look the same, like heads, tails, heads looks very similar to tails, heads, heads. I agree. It's the same outcome. It's 2 heads here and 2 heads here. But from a probability point of view, those are separate events. In this event, the first 2 coins are heads then tails, and in the other one, the first 2 coins are tails and then heads, and those are different. Those have different separate probabilities associated with them. So when you're flipping 3 coins, you're going to have 8 possible events. But now when we want to identify the sample space, we have to decide, well, what is our outcome? Again, this time we're going to call it number of heads. Okay, and so what are all the possible numbers of heads? Well, this one right here, tails, 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 that's 0 heads, okay? Now, this one is only 1 heads, this one's 1 heads, and this one is also 1 heads. So that's another possibility, is to have just 1 heads. This one is 2 heads, this one's 2 heads, and this one's 2 heads. So 2 heads is another possible outcome. And then this one is 3 heads. And so this is our sample space. Our sample space winds up only being 4 possible outcomes, either 0 heads or 1 head or 2 heads or 3 heads. Now, by the way, you could do this instead of calling it number of heads, you could call it instead number of tails. And believe it or not, you'd actually come up with the same set of outcomes because you can have three tails or 2 tails or 0 tails or 1 tails. And so now when we want to identify the probability of each one of these outcomes, basically what we want to do is each event, okay, so each event is going to basically be 1 over the number of events. Okay, so we know that with 1 coin, it's either heads or tails. That's only 2 events. And that means that each one of those events are going to be 1 over 2, or 1/2, which is 0.5 each. So there is a 0.5 chance of getting just heads and a 0.5 chance of getting just tails. But now when we ask about the outcomes, the number of heads, the possibilities are either 0 heads or 1 heads. Well, so what would the probability of flipping 0 heads be? Well, 0 heads would occur if we got tails, and we know that the probability of tails is 0.5. So the probability of 0 tails is 0.5. And then we want to know, well, what is the probability of getting 1 head? Well, we already know that. If we flip heads, again, the probability is 0.5. And so the probability of 1 head is 0.5. And if you add them both together, 0.5 plus 0.5 equals 1. That means all probabilities add up to 1, which is a requirement in probability. Now let's see what happens with 2 coins. All right, when we did 2 coins, we said that there were 4 possible events. First coin heads, second coin heads. First coin heads, second coin tails. First coin tails, second coin heads, or both coins tails. That's 4 separate events. So each event is going to be 1 out of 4, which is 0.25. And therefore, heads heads is 0.25, heads tails is 0.25, tails heads is 0.25, and tails tails is 0.25. Now look at this. I just want to give you a quick preview. Because heads tails and tails heads are both together 1 head, okay, we would combine together their probabilities, and the probability of getting just 1 head between 2 coins would now be 0.5, while the probability of 2 heads would be 0.25 and the probability of 0 heads would be 0.25. So when we look at our outcome number of heads, our possibilities are either 0, and that's this one, 1, which is 2 of them. 2 of the events contribute to 1 outcome, or 2 heads, which is only 1 event. So 1 event, so the probability of 0, that's only 1 event. So that's going to be 0.25. But the probability of 1 head, because that includes 2 events, it's going to include the probability of both of those events, 0.25 plus 0.25 for a total of 0.5. So the probability of flipping 1 head on 2 coins is 0.5, where the probability of 0 is 0.25, and the probability of 2 heads, both heads, is also 0.25. So hopefully that idea now will help us understand when we look at the probability of 3 coins. So now when we look at the probability associated with flipping 3 coins, we know that there are 8 events, right? We made that big chart. We knew that there were 8 events. Now several of them have the same outcome, the same number of heads, but it doesn't change the fact that there are 8 events. And that means that each of the events has a probability of 1/8 or 0.125. So 3 heads is going to be 0.125, heads, heads, tails is going to be 0.125, all the way down the line. Okay, so each one of these is going to be 0.125. So now when we look at the outcome number of heads there are four possibilities, either 0 heads from flipping 3 coins, or 1 heads, or 2 heads, or 3 heads. Now, only one of these events is 0 heads, and that's tails, tails, tails. And therefore, the probability of getting 0 heads is only one of them, only one event, which is 0.125. So 0.125. Similarly, only one of the events is all 3 heads. And so that means that the probability of flipping 3 heads is also 0.125. But the probability of flipping 1 head or flipping 2 heads, each one of those includes 3 events. Look, tails, tails, heads is 1 head. Tails, heads, tails is 1 head. And heads, tails, tails is 1 head. And so 3 events. So I'm going to put 3 times 0.125. And if we do 3 times 0.125, we get 0.375. And so then the probability of flipping 1 head when you flip 3 coins is 0.375. And similarly, the probability of flipping two heads is the same, because look, here we have heads, heads, tails, tails, heads, and tails, heads, heads. And so this one is also 0.375. And hopefully this procedure gives you a pretty good idea of how to identify probabilities of two outcome events and then doing multiples of them. This can also be applied to the situation of, if somebody has, let's say, 5 children, and we want to know whether each child is a boy or a girl based on their, birth order, and, without getting too crazy, this is basically the chart that we would fill out with 5 boys up here in the top left and 5 girls down here in the bottom right. And something like right here would wind up being first a girl, then a boy from here, and then a boy, and then a girl. So this person, their first child was a girl, their second child was a boy, their third child was a boy, their fourth child was a boy, and their fifth child was a girl. Okay, and if you filled in this entire thing, what we would have is, this is 8 events here times 4 events. That's 32 events. And so each event would have a probability of 1 over 32 associated with it. Okay, and so these are just examples of 2 event outcomes where each one is considered basically 50-50. And you can do it with coins, and you can do it with a lot of other things.